Yeah.
All right. Um, so, I am Borsha Das. I am the developer advocate for evmarks.com, and I'm also the organizer for Cube Huddle Toronto 2023. It's a conference around edge computing, DevOps, cloud native ecosystem, and also the empathy side of tech. And today I have the pleasure of being joined by Oleg Shalayev, who is the head of developer relations at AtomicJar. So, without further ado, I would like to add him to the stream, and we can, get started with some of the questions and get to know about AtomicJar. So, yeah. Hi, Oleg. Would you like to introduce yourself?
Hi, Barsha. Thank you for having me here. Hello, everyone. My name is Oleg, and I am currently connecting from Estonia. I work as a developer advocate for, and sort of leading the DevRel team for AtomicJar, which is the company behind Testcontainers libraries. And I have a number of years of experience as a developer, mostly in the Java ecosystem, but recently venturing into other languages as well. And yeah, that's like a short intro, I think.
Awesome. So let's talk a little bit about Atomic Jar and then deep dive a little bit. So can you tell us a little bit about what Atomic Jar is, and then we're gonna discuss and deep dive into the products that are provided by Atomic Jar. So could you just introduce Atomic Jar as a company?
Right. AtomicJar is is a small startup, 2 years old, made by the maintainers of the Testcontainers libraries. Which, incidentally, we have to start talking about Testcontainers, which is one of the products the AtomicJar supports and drives forward first, because that's where this story has started. Around 8 years ago, just a little bit after Docker has been introduced to the world, people started to ask themselves questions: how can they maybe leverage this technology of containers, which 8 years ago was quite new? How they can leverage that for dynamically, maybe programmatically, creating the environments with the required services to simplify testing of applications. If you think about the ecosystem, larger ecosystem, that much time ago, there were still the microservices were in the beginning of the journey. There were a lot of application servers. There were a lot of larger applications in place, and then to run those, people would need service dependencies, real things, databases, message brokers, stuff like that. So the test containers, what it gives you, it's the open source libraries now in different languages, in a number of languages. We have Java, .NET, Node.js, Python, Haskell, Rust, and so on. And they give you the programmatic API to manage, create, configure, and use services in containers programmatically. You would use it. Most classic example would be from the tests, which is thus the name, test containers. And you would use it for your tests to programmatically configure the environment your application should run in. There are a number of cool features of the test containers libraries, like the automatic cleanup, and the API is really, really, really good. That the lead developers are saying, but it's like it gives you the flexibility to declare yourself as a developer, how you want to run your tests. So those open source projects were getting popularity and traction for several years, and then 2 years ago, the maintainers of the test containers Java library, which is currently the most popular and actively used project out of these, created the company behind that. It went great. Now we are having a great time pushing the open source libraries further, supporting open source. The maintainers of other languages like other library implementations in other languages also joined AtomicJar. So we have the test containers Go main maintainer in the company, testcontainers.net, test containers Node, and it's just one of the missions of AtomicJar is to make developers more productive and happier by allowing them to create more robust, more resilient tests that will look and feel like unit tests with the configuration embedded in the IDE, executable like with a single click of a button, but which will run with real dependencies and give you high confidence that the applications that you're working on actually work. Now, through the years, this approach had worked really, really well. And specifically, the transition to microservices and Kubernetes, for example, as the development platform, increased the usage of test containers because the services started getting smaller, and the importance of integration tests or importance of testing with real things you'll be using in production grew, right? So, and with that grew the popularity of the projects. So that's what AtomicJar does. The other product that AtomicJar currently has is Testcontainers Cloud, which is the cloud backend, the sort of the software as a service environment, which can run containers during your execution of test containers-based tests, which is a masterful addition to the whole experience. You are running your test locally. Your test runs locally. You still have all the capacity of setting up breakpoints, changing it rapidly, but you don't have to figure out where the containers are being run. You don't need to mess up with the Docker configuration, either locally on your desktop or in CI. Containers are transparently run in the cloud, in the on-demand provision isolated VMs for you. They don't take the load. You can lean on the cloud for parallelization and scaling. It's a great combination of open source libraries and a service that supports the simplest adoption of that. Testcontainers Cloud currently is in the public beta, so I encourage you, if you're using test containers, I encourage you to check it out. If you're not using test containers, well, most probably you will need to have some test containers tests to make full use of it. But getting started with test containers tests is the easiest with the Testcontainers Cloud offering as well. So those two things are what AtomicJar is working on. And so far we hear very good feedback and lots of agreement how test containers experience is great.
Great. So, since test containers and test containers cloud is pretty much what Atomic Jar, works towards providing to the developers and to the organizations, to make the organizations much more agile. So, my next question would be around what role do you think the test containers play in making developers more productive and the software more resilient?
So test containers approach to making your tests isolated and fully standalone, right? Your tests become independent of the like third-party configs or environments provided by your platform team or by your CI platforms. Your tests drive the environment where they're being executed. The configuration is always up to date. The tests and the configuration, the environment configuration is in the source code. So that means everyone, literally, who touches the project execute the same tests in the same way, giving you very high reliability and confidence in that the tests are actually working the same way. That means you can make, and by everyone, I mean your colleagues, but also your CI platform. That means the CI environment can become the single source of truth for what things work or not. And that means that you can actually build automated pipelines for delivering features much easier. You don't need, if you rely and you have great automated test suits for determining the quality of your code, you don't need to have a bottleneck on staging environments. And test containers gives you this flexibility of the setups that you can achieve. It also you're not just building CI pipelines, because the same execution of the test is possible locally on your workstation. It gives developers the option to reproduce failures in the same way very efficiently. So if something doesn't work in CI, you literally can run the same test with the same configuration, with the same versions of, I don't know, Kafka or Elasticsearch that your application was tested in CI, and you can locally set breakpoints and very quickly understand what is going wrong. So the whole testing is shifting very much to the left, because to fix any problems, you do need to go back to development, right? Like no one else besides developers will fix things. Well, the title is not important. The fixed things will be fixed in development, right? So shifting testing left makes developers the feedback cycle much tighter, and having more reliable tests gives you more confidence in your stuff. So, and well, it all comes without any hassle, right? So like you don't need to maintain the environments. All you need to have is the access to Docker, a compatible Docker environment. So it doesn't make the tests a chore. So tests are become just a natural part of your development cycle, and you can have much higher velocity of delivering software, which is, I think, the one of the main things that makes developer happy. Like when I feel productive, I'm happy as a developer. So hopefully that's the same true is for other people.
You really touched a very important point, Oleg, that if you feel productive, then only will you be able to deliver the best impact result. So that kind of brings me to asking you this particular question, like, what do you think? What sets the test containers cloud apart from the other cloud-based testing solutions which are currently available in the market?
That's a that's a great question. That's a great question. So uh, I would not claim the utmost expertise on cloud-based testing solutions, uh, but I can tell you what we see when people start using Test Containers Cloud with Test Containers Best Tests, and what they tell us as the feedback. So Test Containers Cloud is a like sort of a domain specific cloud for running containers during Test Containers tests. So it's not like a general purpose cloud where you would run your machines, but the Test Containers experience with using and running test containers tests with the Test Containers Cloud, it works out of the box because it's a very specific niche uh, use case that we are helping people with, and it works in all environments with the complete regularity. Like it just literally works on CIs, whether you use Intel machines, ARM machines, Apple Silicon Macs, Windows with Linux subsystem. It just works, and it gives you this programmatic approach to the tests. So most commonly used cloud-based solutions for testing concentrate on uh, easier creation of staging environments, or easier creation of provisioned environments that you would statically assign to developers in some shape or form, or statically assign to like pull requests to run the tests. This is a good first step towards shifting tests left, but with test containers experience, you actually can make developers empowered to run any single test that you have locally in a matter of pressing a single button, and the rest is taken care of programmatically. And so this is one thing. And the other thing that sets test containers experience and test containers tests apart is the huge ecosystem of modules. Test containers provides you, the open source libraries give you the API So you can run anything in Docker containers. But what is massively, massively successful is the abstractions that the community has built on top of those low-level API. So as an application developer, I don't need to specify I want to run this Docker image, expose this, port, run this command to actually set up my, I don't know, Postgres database in a particular configuration. I will just use a library that also already has that configuration embedded. So I will just say like, please give me a new Postgres container. And only if I need to configure some specific things, I will do that. And the same as well with other technologies. I'm not sure I know or I could very easily create a recipe how to run Kafka in a container, or how to run a Kubernetes cluster in a Docker container if I'm, for example, testing Kubernetes operators. But with the ecosystem of modules, I can very easily do that because other people put effort into this and created those reusable libraries that they can use like any other library. And as a developer, this is what I do every day, all the time. I'm just writing code. So the programmatic approach and the collection of modules are setting the test containers experience apart. There is no configuring like wallpapers of YAML to get the services running. There is no static configuration to run clusters of things. Um, Everything is programmatic. Everything is available in your IDE with just you type dot and you see what IDE suggests you to do, and you pick the best options. So it gives power to developers to extent that I don't think any other cloud-based testing solution currently does.
Great. So, how do you personally look at the adoption of containers and containerizations evolving over the next few years?
Well, yeah, that's a good question. That's a very wide question, right? So I think containers will be the de facto standard for deployments of all sorts for the foreseeable future. Uh, for example, like I don't think like the WebAssembly based formats for deploying things will take over or like massively grow in popularity in the next 3, 4, 5 years. They might, but I don't think the containers are going anywhere. So, and the containerization is not going anywhere uh, as well. So we use that for two things. One is we offer that to run our applications as the application developers, uh, and that will not change very much. But the other thing is we offer containers, and the vendors of technologies offer containers to run their things locally. That copies like for sort of the normal technologies, like for technologies like databases or message brokers, there is a very natural step to running things locally, for example, for test purposes or for creating local development environments. Very naturally, you just run a container with a database or message broker. But more and more cloud technologies also get emulators and or like sort of compatible local execution products that allow you to run sort of the cloud stack locally, and that gives power to developers to run and develop locally and test locally without actually using the cloud accounts uh, 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 for accessing those technologies, right? So, for example, local stack for AWS, right? Which is a completely local version of AWS stack. Of course, there are performance differences and the availability differences. You can compare like a one container implementation with the actual AWS cloud. But functionally, it provides you with the same services, so you can test locally. And I think that will go forward over the next years massively, massively, massively. Uh, Google Cloud, for example, provides emulators for some of its services, and I'm not saying like some cloud services are also just managed versions of something that you can run locally, like I don't know, managed Elasticsearch um, or managed Kafka in the Confluent cloud. So there you can use the local Docker images that are already available to test, and then you just deploy to the cloud for production. But actual like cloud native services can become more and more accessible locally via the containerization, and I think that will happen more and more.
Great. That's honestly a great perspective that you shared. Now, this is a question of high concern, Oleg. That is, how does Atomic Jar work with developers to help them adopt new technologies and best practices in their development workflows?
Right. Oh, this is a very close to me question because Atomic Jar's DNA, sort of how it all started. It's all started from the open source. At the core of our work is still taking care of the open source projects and driving them further. Um, we do quite a deal of care into. We are trying to make sure that documentation is up to the standards. We are working very hard currently on bringing all our maintained implementations of the test containers library to the same standard. So the different language implementation share the common vocabulary, the common feature sets, and of course, as the developer relation team, we are trying to create both educational content, uh, but also inspirational content. I feel like very much sometimes people and developers just don't realize what what can be done very, very easily with technologies that we have available today. And so we participate in conferences, we participate in local meetups, and we are trying to, well, come to little video podcast style uh, gatherings like the current one to spread the word about how you can turn your tests into a truly enjoyable part of your day-to-day work that empowers you rather than sets like limits to what you can achieve. Recently, for example, we started the initiative to create how-to guides for using test containers. Not just the documentation that talks about like a typical open source projects which talk about like sort of a reference manual, what is available, what API is available, but a very developer-centric approach, how to get started with test containers when you know nothing about the project, and sort of little bit. It's of course it's not ideal, and we would improve that over time to come, but there is already some beginnings of the learning path to drive you through what are the test containers, what are they offering, how you can get started with it, what are the best practices, how test containers libraries mitigate and guide you into using the best practices or using things that you will thank us later for. For example, when we run containers, we take great deal of effort to ensure that everything that is mapped on the host machine is randomized. For example, the ports, right? Because if you're not doing that, if you're using static setups, you cannot parallelize things efficiently, and that is one of the most straightforward ways to improve the performance of your CI pipelines, right? So we are trying to guide you into using the right things straight from the start, and then yeah, hopefully the community will appreciate the efforts and spread the word further, and use the libraries.
Thank you for answering that question. Now, I would want to, talk about this particular issue. That is, security and reliability has kind of become the talk of the town. And even in the last KubeCon that I visited, security had a specific spot in the conference. Everybody started talking about it. So my next question would be regarding Atomic Jar's effort in ensuring the security and reliability of its product, especially in the context of cloud-based solutions.
Right. So, yeah. So I cannot comment with authority on the particular security practices, but Testcontainers Cloud gives you isolated virtual machines in the cloud. Um, it's a multi-cloud deployment. It's an edge deployment that gives you the worker nodes from different clouds based closest to your location. It uses the SSH tunnels to protect the traffic between your tests and the isolated cloud VMs. So we work with all necessary security requirements in mind for ensuring security and reliability of our products, which is the multi-cloud strategy is for one. But what you said is also the first part of the question is that security is a very, very big topic for everyone, including supply chain security and questions like that. Right? And there are two answers that we currently have to sort of security problems, right? And not just today, but like in general, they're very, very generic. One is discovering vulnerabilities, and two is fixing them, preferably faster than they can be exploited. Right? So discovering vulnerabilities is something that the professionals and security professionals should be doing. Right? It's very, very hard for like an arbitrary person from the street to say that certain things are vulnerable or not. But fixing your things as a developer, this is the responsibility of every developer themselves, which means that once the vulnerabilities have been identified and once the patches have been delivered to, for example, libraries or as the recipes for how you should change your code yourself, you need to roll it out to production. And the time is of an essence there. So here's the question. What is one thing that can ensure that you can roll out changes to production very efficiently without bottlenecks? And the answer to that is, of course, reliable automated test suites that you trust. When you need to update the library to a different version that has been, like, the previous version has been compromised, you update it. And then can you roll out those changes immediately? Well, you don't know whether the fixes actually broke anything in the application. For example, a few years back in the Java ecosystem, there was a very giant vulnerability discovered in the logging libraries. Right? It was. I don't think there was a remote code execution, but it was the logging library would call a remote LDAP server based on malicious input. So that meant that any line of code could log anything if you log your user input with in some cases, your servers will call external LDAP servers and give them the data. A huge vulnerability in the very commonly used logging libraries. So every application, literally every Java application, almost every Java application was affected. Right? The fixes were fairly trivial, and the initial hot fixes were to disable this functionality of that wasn't just logging strings. It was a little bit more sophisticated, including regular expressions or environment lookups, which most projects probably didn't use. So the fixes were to fix that. But you get this updated version of the library. How do you know that you can actually use it and it doesn't break your stuff? That's where you need tests. That's where I think AtomicJar can help, and our products can help developers very, very much regarding the security. it's the mindset.
Yeah, since you mentioned about the mindset, so I would like to know how does Atomic Jar plan to continue innovating in the development tooling space and stay ahead of the emerging trends and technologies?
Uh, that's that's a very very good question. So the our current focus lies on pushing the test containers libraries further and well getting test containers cloud as a product to general availability. Currently it's in the public beta, so there's still work to do to ensure that it works with the worldwide capacities and handles anything that you throw at it. It's currently used by many companies, but it's not fully like GA yet, right? So that is a big priority for the company. Uh, but the test containers libraries themselves are in a good spot currently. Uh, there are several initiatives that we are pursuing. Uh, One of them is which was very recently announced, the official modules initiative, where AtomicJar partners with vendors of the different technologies on the co-maintaining and of co-maintaining those libraries that make sure that application developers can test against the particular technologies with just one or two lines of code, creating those environments with test containers. We have a number of partners currently. We will expand that initiative to get more technologies on board. So that is a part of that where it's not just AtomicJar drives forward the simpler and better ways to test the applications, but also the vendors of the technologies also acknowledge that it's a great option for testing applications that works for multiple different languages. And so that is one direction where we would try to stay ahead of the emerging trends and support more and more different technologies. And the other one is, besides, there is nothing inherently test specific in the API, for example, that test containers libraries offer you. It's just a generic API that allows you to run things in containers with great flexibility and ease. So this is something that is already happening in the Java ecosystem, for example. Application frameworks making use of test containers to create those ephemeral environments for the applications to run in. Not to run your tests in, but to run the application themselves. So when you develop locally, you don't need to provide that execution environment. You don't need to run your Docker Compose files. You don't need to set up the environment locally, including like random services the application needs, but you can just run your application. And if some environments, like your database is not configured, or like there is no Kubernetes cluster configured to if your project is an operator, right? You don't that configuration is missing. The application framework will provide you with the target like that via test containers. So this makes local development a much happier place, because as a developer you can concentrate on the code, and as a developer you also get a measure of consistency how the whole team runs your project. So that would be an excellent opportunity to expand in the other language ecosystems for the local development environment creation. I think like, so personally, knowing how and using the like developing applications before without those integrations, and after developing albeit smaller microservices with for example Quarkus, which is one of the Java applications that supports this, and having the support of those Quarkus dev services integration with test containers, that is like just a day and night difference makes you happier as a developer.
Thanks for sharing that. So I would want to know from you, if you could just, explain to us briefly that, about a project or a case study where Atomic Jar's product were actually instrumental in improving the efficiency or the agility of the organization's development process. If you could just briefly touch upon that.
Right. Yeah. Yeah. So the Testcontainers libraries are very, very, very popular, right? And one example where integration tests are essential and where the projects deal with the magnitude of different technologies that they need to integrate with is, for example, the observability libraries, the and other like, for example, CNCF projects that need to collect metrics or work with metrics. So one example of that is, and there are many, many more, but my go-to example to show is the Telegraph by Influx Data, right? So Telegraph is the CNCF project, and it's an, I think it's CNCF project. I apologize if it's not, but it's an open source project, and it allows you to collect metrics, and it integrates with sort of the producers of metrics and the consumers of the metrics that it passes along, right? So it needs to integrate with all the technologies like Kafka or Prometheus and this and that. So they need to test everything on all those combinations, right? So how do they do that? They do that by using test containers. Maybe not everywhere, but a large chunk of their tests are including test containers. And Telegraph is written in Go, which also I like very, very much because it's an example a little bit further away from my home Java ecosystem. And it also shows very, very much that the test containers approach is relevant not just for Java. Right. So you can take a look at the source code. It's an open source project, so it's all available on GitHub. Check how they run tests, how they spin up the clusters of Kafka deployments, like separately Zookeeper, separately Kafka, organized it into network using Test Containers API. And I think that makes their task of keeping the open source project well integrated with wildly different technologies much, much easier.
Thank you for sharing that. So, here's a subtle plugin that I want to do. That is, we are proud to announce that Atomic Jar is the community sponsor for Cube Huddle. And let's hear from Oleg as to what he thinks, you know, getting associated with Oleg, getting associated with Cube Huddle is going to bring for this particular partnership. Let's hear from him. So, Oleg, what do you think, as one of the community sponsors for Cube Huddle Conference, what do you hope to achieve through this partnership?
We we would love, as AtomicJar is a company built by developers, and our products are dev tools. So it's a bit of cliche of saying like for developers by developers, but with our very strong roots in the open source libraries, I think that is actually true. So we love supporting local events. We love supporting meetups and conferences where we can spread the word about what we think is a very, very good approach that makes developers more productive, and not just individual developers, but the teams, right? Because that's where the benefit lies. Like when everyone takes care and writes and runs tests and trusts the tests, the whole team moves forward faster. So Kubernetes is, well, and widely popular technology, right? And it's at the heart of any cloud cloud discussions nowadays. So supporting Cube Huddle and maybe making sure that talking to developers, somebody from AtomicJar will be participating in the conference. Um, so learning what are the current trends and questions that are at the like bleeding edge discussions in the Kubernetes community, how we maybe help with our products for that community, the learnings, and that is essential. And we would like, in general, we would like to support the communities because we know how hard it is for developers to think, not just individual developers, how hard it is to get out of your day-to-day routine and think about the larger, better ways to do things. Like everyone is slammed, everyone is having their task tracker full of things. There are product owners who are asking when their particular features will be done. There are angry open source users on GitHub asking like why my issue hasn't been fixed immediately when I just submitted it at like 3 a.m. last night. Uh, it's overwhelming, and especially in the super connected world like that. So conferences and meetups are uh, at the heart of the community, where you can talk to like-minded individuals. So I think it's very, very important for the initiatives like that to continue. Um, and yeah, from Atomic Jar, would just love supporting local events.
Thank you. Thank you for sharing that. So, for a conclusion, I would like to ask you that if you could, in a nutshell, just walk us through quickly of how you see Atomic Jars' product and services contributing to the overall growth and success of the tech industry as a whole.
Yeah. Okay. So in general, it's not even the success of the tech industry as a whole. I think we know how to create software, right? And we know that this is a complex and hard project problem. And one thing that we know improves the quality of software is good tests, right? Not just the immediate quality of software in the particular moment, but through the whole life cycle of the maintenance, right? Having good test coverage and decent tests makes that you go from anyone can break my code, literally, if you have no tests, right? You go from that to nobody can break my code without me noticing that and without like getting into discussion with me into that. Of course, you can still evolve things, but you get this maintainability of software for the much, much longer time, which is which improves quality. And hopefully, by improving quality of software, we can improve the quality of life for many, many people in general, right? Fewer outages, fewer glitches, uh, the applications that actually work the way they're intended, uh, that can have massive, massive impact on the life in general, and then also allow you to move forward safely, right? There are massive, massive amounts of systems that have been written in the last 50 years. Uh, some of them probably with just a handful of people who understand how they work. So to evolve them further, to understand, to safely, without like, let's break everything and move fast and break everything, we tests allow us to go into this. Let's move fast and predictably know what things will be broken uh, mindset. And I think that can help the industry to be more grounded, but also more productive in general.
Thank you. Thank you for sharing that. Um, so,